Welcome, ladies and gentlemen. As we all can see, sometimes when the sun and moon arrives, it appears to be very much larger in the horizon. When it's then later in the evening or daytime is going up in the sky, you will see it in a smaller size. And a funny little thing is, if you stand and watch the sun and you see, oh, it's bigger, then try to stick your head between your legs and look at it. Then it will appear the normal size as you see it when it's high above in the sky. What I suspect and think is that is all the flat Earth models where you have a kind of sky dome or firmament above, it's depicted way too high. It's very much lower and wider as the little kind of animation I made. Don't take it to scale model. It's just to give an idea about what I'm meaning. It's lower and wider. So when you see the sun and the moon just arriving, you actually see it via a lot of more water, and therefore it appears to be larger. It doesn't take so long time before it then is up in altitude relative to where you're looking at it. So you again it will appear normal in size in a matter of like a half an hour, 40 minutes or something like that, depending on. Depending on the speed of both the sun and the moon when they arrive. That's those are different and different times. If the sun, for instance, is near the center point, the Tropic of Cancer and not the Capricorn, then it's further inside and it's also lower. But more on this on my moon special, so I will wait for this. But I would like to comment on this because this horizon and all this perspective, and there's a lot of right now with telescopes and people are looking. You're not via telescope, but you, for instance, are looking like on a high rise or something like that. It's like 60 miles, 70 miles at tops. It's not that much air, because what I suspect still, even in the model where I show the sky dome is very low, is still like perhaps 10,000 kilometers up. So it's a lot of more water, and that will work like a kind of lens distortion to your eyes. It can also be the dielectric magnetic energies which are in the air, who also maybe are influencing the way we are looking at it. I don't know, but what I'm sure of, my theory is at least that is, of course, you are seeing it through a lot more air when it just arrives, and therefore it looks much more bigger. But the funny thing is, you can reverse this optical illusion by sticking your head between your legs. So I think it's worth to take notice of inside the flat Earth community, because a lot of fuss is going on with this perspective. I know it's ODD TV versus Cody Lab, and it's hilarious to watch. Cody's lab, he's using a telescope, which is perhaps the most worst to use in daylight conditions, but that's another story. It's very funny to watch, but still, try next time you see the sun or moon. Stick your head between your legs and then wonder why. Hope you enjoyed this little information. Goodbye and have a nice day on the plane.
Have you ever noticed how the full moon looks bigger when it's near the horizon than when it's high overhead? If so, you're not alone. People have wondered about this strange effect since ancient times, and surprisingly, we still don't have a great explanation, but that's not for lack of trying. Some of the greatest minds in history, Aristotle, Ptolemy, Da Vinci, Descartes, have all wrestled with this problem and failed to generate an adequate explanation. One of the first ideas suggested was that the image of the moon in the sky really is bigger near the horizon. Perhaps the Earth's atmosphere acts like a giant lens, magnifying the moon as it rises and sets. But this explanation doesn't cut it. If anything, the refraction of the atmosphere would make the moon look slightly smaller. Plus, if you actually measure the size of the visible moon at different positions, it doesn't change at all. But then why does it still seem bigger when it's rising? This must be some kind of optical illusion. The question is, which one? One explanation is the Ebbinghaus illusion, where two identical objects look different because of the relative size of the objects they're surrounded by. Here, the two center circles are actually the same size. Maybe the moon looks bigger near the horizon because it's next to tiny trees, houses, and towers in the distance. But when the moon is higher up, it's surrounded by the vast darkness of the night sky and looks tiny by comparison. Another possibility is the famous Ponzo illusion. If you've ever tried to draw in perspective, you know that the closer something is to the horizon, the smaller you should draw it. Our brain compensates automatically for this by perceiving objects near the horizon as larger than they actually appear. The two yellow lines in this drawing are the same size, but the upper one seems bigger because we interpret it as receding farther into the horizon. So between Ponzo and Ebbinghaus, it seems like we've solved the mystery of the moon illusion, but unfortunately, there are a few details that complicate things. For one thing, if this was just the Ebbinghaus effect, then we would expect the moon illusion to disappear for pilots flying high above the clouds, since there wouldn't be any other smaller objects near the horizon. But in fact, pilots and sailors out on the ocean still claim to see the moon illusion. On the other hand, if it's just our brains auto-correcting the size of objects near the horizon, then we'd expect the moon illusion to be visible inside a planetarium, where the whole sky, including the horizon, is displayed on a spherical dome overhead. Studies have shown, though, that this is not the case. To make matters worse, it seems the moon illusion disappears entirely if you just bend over and look at the moon between your legs. Now this is just getting ridiculous. One of the most promising explanations today is known as convergence micropsia. Our brains judge the distance to objects and their apparent size by the focus of our eyes. When looking at the horizon, your eyes focus far off into the distance, so your brain knows you're looking far away. The moon appears a certain size. Your brain thinks it's far away, which it is, so you naturally conclude the moon must be big. But when looking up at the night sky, there's nothing for your eyes to focus on, so they default to their rest focus, which is a point just a few meters away. Now your brain thinks the moon is much closer than it really is, so you naturally conclude the moon's not as big as you thought it was. Rather than explain why the moon looks so big near the horizon, convergence micropsia explains why the moon looks so small when overhead. Still not satisfied? Well, frankly, neither are many scientists, so the debate over the moon illusion still rages on and may continue as long as we still see it in the night sky.